Now that we've got the sun, earth, and moon, we can start talking about eclipses. There are two broad categories for eclipses. First, we're going to talk about the solar eclipse. A solar eclipse occurs when the moon's shadow falls onto the earth. For the moon shadow to fall on the earth, it must go sun, moon, and then earth. So what phase is the moon going to be during a solar eclipse? It is going to be in new moon. We can only see a solar eclipse during new moon. So from our point of view here on the ground, we're going to see the moon cross in front of the sun, blocking some or all of it. The other type of eclipse is a lunar eclipse. A lunar eclipse occurs when the Earth's shadow falls onto the moon. So we have sun, Earth, and then moon. So what phase are we going to be able to see lunar eclipses? Lunar eclipses will only occur during full moon. Now, from our point of view on the Earth, we're going to see the moon become darkened. However, it seems like it should go black. It actually doesn't. Because of the Earth's atmosphere, a little bit of the sunlight actually gets bent, refracted, so that it actually hits the moon. So in this case, it actually turns into a deep, dark red. If you've ever heard the term a blood moon, those usually refer to a total lunar eclipse, where the moon is completely within the Earth's shadow. Exactly what we see right here. So we see the moon turn this reddish color as the light is being bent. Here is our fourth clicker question. A solar eclipse can only occur during which phase? A, full moon, B, first quarter, C, new moon, or D, third quarter? Go ahead and think about it, and we'll discuss in just a bit. All right, so for a solar eclipse, the moon's shadow must fall on the Earth. So it has to be sun, moon, Earth. If the moon is in the middle, the Earth only sees the dark side of the moon, which means it has to be C, full moon. We will only see a solar eclipse during new moon. We will only see a lunar eclipse during full moon. Now, some quick definitions. You may have heard of a meteor or a meteorite. A meteor is a piece of space rock that is falling through the sky, falling through the Earth's atmosphere, it becoming so hot from friction that it's actually burning and glowing. So the shooting star is the same thing as a meteor. If the lump of space rock actually lands on the Earth so we can pick it up, it is called a meteorite. However, this piece of space rock still in space is referred to as a meteoroid. So it is a meteoroid if it is still in space, it is a meteor as it falls through the atmosphere burning, and it is a meteorite if it is landed on the ground so we can actually pick it up. Now, we still have some other objects within the solar system. It's not just planets and dwarf planets and moons. There are also the asteroids. Asteroids are relatively small and rocky objects that are orbiting the sun. These things can be fairly large, but the reason I say they're relatively small is they are so small that they don't actually have enough gravity to become rounded by gravity. All of the planets and dwarf planets have enough gravity that they're nice and round. These things have weird, deformed shapes. Most asteroids are located between Mars and Jupiter in what we refer to as the asteroid belt. Although that's where we have the highest concentration, that's not the only locations where we find asteroids. We actually find them all throughout the solar system. Some of them even cross the orbit of the Earth. These ones are referred to as near-Earth objects, and we're very interested in finding and tracking all of them because these are the ones that have potential for actually crashing into the Earth. Generally, if we have a chunk of asteroid that falls on the ground, it looks just like any other Earth rock, so most of them are completely unnoticed. However, occasionally these will land in Antarctica on ice, and there are very few ways for a rock to end up on top of the ice in Antarctica. So because of that, a lot of meteorites are actually discovered in Antarctica. Comets are another as a set of space debris. These ones are both rocky and icy. These must have formed in the outer solar system. Asteroids, being made of rock and metal, must have formed in the inner solar system, but comets are formed in the outer. They have a composition of about 50% rock and metal to about 50% ices. I really like this description that they are dirty snowballs. Most of the comets are located in a region just beyond Neptune we refer to as the Kuiper Belt, and we have hypothesized another possible region right at the edge of our solar system referred to as the Oort cloud. We have no actual direct imaging of any object in the Oort cloud, but we think that it exists to help us explain certain types of comets that don't fit nicely into the Kuiper Belt. All of the comets that actually come into the inner solar system have a very elliptical, meaning very stretched out, elongated orbit that takes them all the way from the edge of the solar system down to the sun and all the way back out. Now, as these comets are approaching close to the sun, remember they're made of mostly ice, this ice is going to begin to vaporize, which creates the kind of classical view of a comet. So far away from the sun, we have the dirty snowball, this mix of rock and ice, but when it is cold, nothing's going on. However, as it gets closer and closer to the sun, some of the ice begins to evaporate and sublimate, which will give the comet what we refer to as a coma. Okay, that's this kind of head surrounding this icy object. As it gets closer, the solar wind is actually able to push some of the material away from the comet, starting to create its tail. And then, because of sunlight, other particles are also getting pushed away from the sun, so a comet's tail is actually always pointing away from the sun because it is sun pressure that is creating it. So after it gets its closest approach, then it begins to move farther away from the sun, moving back out to the outer solar system. But as it does, it cools off, so the tail and eventually the coma go away until it's back in the outer solar system. So comets only have tails as they're in the inner part of the solar system. Here is our fifth and final question. The tails of comets point in a direction A, toward the sun, B, away from the sun, C, at nearly right angles to the sun, or D, none of the above. Go ahead and think about it and we'll discuss in just a bit. Alright, so what happens with a comet's tail? The tail is formed as pressure is pushing material away from the sun. So it is B, away from the sun. The solar wind blows the tail in a direction away from the sun.